Welcome to the 9R notes. It's really 9R2 notes. It's the review of 9.3 through 9.6 on solving quadratic equation notes. So let's take a look. We have 8 questions only, and we're supposed to use the best technique for all. So what I like to do is, again, reference my intro notes. I know that I'm not going to use graphing for any of these. So I'm going to try to locate all of the questions that square roots would work best. Remember, square roots is when it's just a squared term and some constant. A squared term and a constant. You don't have a plain x to the power of 1. You only have a squared term. Here's a squared term or a squared term and a constant. So I'm going to look through our notes and see how many that technique would work best for. So if you haven't printed these, make sure you print it now. If you haven't copied it down, do it now, because we're not going to do this in order. We're going to spot different techniques and when they would work best. So let's look at question number 1. Question number 1 would not be square roots. It has a middle term. Let's see question number 2. Question number 2 has a middle term. It would not work with square roots. Remember, square roots can only have a squared term and a constant. Let's look at this one. Ooh, question number 3, I have a squared term and a constant. This one's square roots, definitely. Square roots. So let's go ahead and do question number 3. So the first thing I'm going to do is square root both sides. Take the square root of both sides. I'm going to have 5n minus 2 equals plus or minus, I need to take the square root of 144. So the square root of a square is just what was inside, so that's what we have left. And the square root of 144, well, that is a perfect square. It is 12. And now we separate that into 2 equations and we solve. We have 5n minus 2 equals positive 12. We have 5n minus 2 equals negative 12. And go ahead and give those 2 a little whirl. Go ahead and solve them. So I'm going to add 2 to both sides here. I have 5n equals 14. N equals 14 fifths. You could turn that into a mixed number, but you don't have to. I think that is a great answer to have. So let's go here. We're going to add 2 to both sides. Remember, we do the opposite when solving. So the opposite of negative 2 is to add 2 to both sides. So now we have 5n equals negative 10. Negative 12, go forward 2, is negative 10. I'm going to divide both sides by 5, and I have n equals negative 2. Beautiful. Let's keep going. We're looking for problems that square roots would be the best technique. Number 4, that would not be a good technique. We have a middle term. Question number 5, square roots would not be a good technique. We have a middle term. 6, whoa-ho, howdy. We just found a great problem for square roots. We have a squared term and a constant. So I'm going to add 100 to both sides. I have k squared equals 100. We're going to take the square root of both sides. K equals plus or minus 10. Great. Let's go to number 7. 7 is not a good question to use for square roots. Nope, because we have a middle term. And question 8, square roots would not work. We have a middle term. Great. We have found all the questions on this worksheet where square roots would work best. And there were 2. There were only 2 out of all of these where it would work best. So if we go to our next technique, which is factoring, let's see how many of these questions are factorable, okay? So let's see. First question. Think of all the numbers that multiply to give you 24. Do any of them add to give you 10? But not just any 10, a negative 10. Definitely, that's factorable. So what multiplies to give you 24? You have lots of choices here. There's all of our factors of 24, 1 and 24, 2 and 12. We have 8 and 3 and 6 and 4. Looks like it's going to be 6 and 4. Negative 6 and negative 4. So those 2 numbers do multiply to give you a positive 24, and those 2 numbers add to give you negative 10. We set those 2 chunks equal to 0, and we solve. So x is going to be 6. And x is going to be positive 4. Great. Let's look at the next one. Are there any numbers that multiply to give you 62 that subtract to give you 10? And there are not. This is not factorable. It's just not possible. So let's look at question number 4. Because we've already done question number 3. Question number 4, is it factorable? Can you think of two numbers that multiply to give you negative 16? Let's think of all the numbers that multiply to give us 16. There we go. Those all of our choices, all of our factors. Which two multiply to give you negative 16 but subtract to give you a positive 6? Well, that's going to be n plus 8, n minus 2. So 8 times negative 2 is negative 16. Check. 8 minus 2 is positive 6. Check. And now we're going to set these two chunks equal to 0 and solve. So I have a negative 8 and I have a positive 2. Those are my two answers. Beautiful. So let's look at question number 5. What are the factors of 3? Well, 1 times 3 are the only things that multiply to give you 3. Do those add to give you 9? Nope, not factorable. So we're on the factoring technique right now, so that's not possible. That cannot be factored. We'll have to use a different technique. 6 we already have done. 7, definitely factorable, Mr. 7. So I'm thinking of all the things that multiply to give me 6. That's 1 and 6, 2 and 3. Do any of those subtract to give you negative 1? Definitely. So we're going to have x minus 3, x plus 2. Negative 3 times 2 is negative 6. Check. Negative 3, go forward 2 on the number line is negative 1. Check. Now we're going to set each one of those factors equal to 0 and solve. Positive 3 and negative 2. Great. So question number 7 is done. Now question number 8. Let's see what we got. Things that multiply to give me negative 3 that subtract to give me 7. There are no two numbers. Nope, it doesn't exist. Because 1 times 3 does not subtract to give you 7. So that is not factorable. So this is the end of this video. Please go to the next one and we'll use our last two techniques to solve the rest. Bye.